Let's discuss a new topic, architectural design. This is also from Pressman book. So as we discussed in last chapter, there are architectural design, conceptual design, data design, etc. But the question is, why we need an architecture? So the architecture is a blueprint of the software, and it enables the programmer, the software engineer, in analyzing the effectiveness of the design to check whether it is meeting the requirements or not. We can also see alternative structures to check whether they would be more appropriate, and we can do this while designing is not complete. The changes are still possible easily. And of course, to reduce the risk associated, because at the later stage, a lot of money, a lot of effort would have been invested, and it would be very, very difficult to change something if something goes wrong. The architecture is a representation of the structure that enable the communication between all stakeholders. It is not the detailed design, it is a small and a concrete map that what the system is having and how it is structured. Using architecture, we can see the design decisions which we have to make early, and that would be having a great impact on the whole process of software building. The IEEE standard 1471-2000 recommended the architectural description of software intensive system or of computer-based system. It would establish a framework and a vocabulary for the designer and will provide the detailed guidelines for representing the architectural description. And the architectural description is defined as a collection of products to document an architecture. Although this is standard, and generally we follow some standard in the software building process, there are some local standards followed by the organizations, and that may vary from workplace to workplace. So wherever you would be working, you should follow the standards which are getting followed in that particular company. Architectural genres, they are generally the specific category in a given domain of software development, and in each category there would be many subcategories. If we have buildings, inside the building we would be having like houses, condos, studios, apartments, industrial buildings, godowns, etc. So let's take an example here. Why this slide is important. This slide is talking about a broad category called building, and then we have different styles. For example, you are making few apartments in a building and calling it a building. I'm making many houses on the ground and calling them buildings. Somebody is making a company, let's say software company, somewhere and calling it a building. So what kind of building it is, what kind of subcategory it is, it would be having a particular style. The apartments would be of apartment type, where you would be having many apartments on each floor. They would be having common elevator and common parking area, and it would be a multi-story. Similarly, if you are making few corporate buildings, they would be having different floors. There would be no closed area like apartment, no room. There would be multiple cubes, and there would be extra light everywhere compared to the apartments. There may be multiple entries and multiple exits on each floor, and there would be emergency exits and fire security issues at corporate building. You can have the emergency at the apartment also, but that would be different. So whatever type of building you are going to make, if you have some idea, okay, I have to make few apartments, I have to make few condos, I have to make few two-story houses, you already know what you have to make. You get some idea, and that we call style. You will get an impression what you are going to make. You get your basic idea, your basic style, you further have to go for specification in that category. If you are making an apartment building and you have to make apartment, you can say, I would like all apartments sea facing if the sea is closed. Or you can say, I would make every apartment spacious. Or you can say that I would do extra security features in each apartment. So in the apartment style, these are extra features. These are specific features which you have to specify once you choose the style. So in the architectural design, there are some predefined styles where whenever you have to do a computer-based system development, normally we call software development, because we have to deal with software, so every development will be the software development. So there are predefined styles like data center, data flow, call and return, OP, and layered. And in each of these, we have some basic things like components, connectors, constraints, and semantic models. So the components of any system would be like data, computational functionality. Then we have connectors. We also call them interfaces, which would be connecting and doing the communication. We would be having few constants that we may get from the real world, what our system can do and what cannot, and how the components in the system would be integrated, and the limitations on the components would be applied. Semantic model will tell the designer wholeness property of the system by looking at the properties of its constituents parts. So now in these styles, as you remember from last lecture, the layered architecture we have seen at different places in operating system, in kernel design, in computer networks, at many places. One style where we will focus more later, that is OOAD, Object Oriented Analysis and Design, which is focused on OOP. And object-oriented design is quite popular these days. There are other models also which are being used in the industry, but OOAD is very popular. So let's see few architectures. If you have a system where there are multiple people who would be doing the entries, and there would be simultaneously checking of the data, data can come from multiple places, can exit at different places. In that type of system, the data-centric style would be useful. And based on this, we have the similar structure we call the blackboard, which would be useful in implementing the data-centric architecture. Here, the data design, which is the core part of the design, and in most of the system, or you can say in all of the system, because data is everywhere, data modeling, data representation, choosing the data type, and how data would be accessed and modified by different functions and the users are very important decisions. And based on that, you have to decide further how your system would be handling the data and what type of structure and the style you have to choose. Pipe and filter, very popular style. Here we have different pipes where these would be having connectors, and we have the data at different components and getting processed, maybe in parallel like you can see here, or maybe in sequential like here or here or here. So data is getting modified or manipulated or processed at different levels in components, and each component we call it filter, and then finally we are doing the communication through the pipes. If there is no parallel architecture in data processing, the pipe and filter will become the sequential model. Call and return architecture, and this is the diagram probably you have seen in the data structure class, where based on your software requirements you have to check whether you really need this style. Here a function will get called, and then further it will be divided into some categories. Let's say M is divided into A, B, C, A is divided into D, E, and D is again divided into F, G, H, and then F and G are going to I. So how the functions are getting called and what is the depth of the function call, those are quite important, and your software's performance may be affected by these. So when you are choosing the style, make sure you really need this style. Layered 1, as we said, that this is a quite popular structure, have used at different places, and this is normally used in standard software. Here, the inner layer can communicate with the outer layer, and let's say layer number 0 can communicate with the layer number 1, the core layer with utility. The utility can communicate with the application layer, and application can communicate with the user interface. The core layer cannot communicate with application layer. So in layer there are some restrictions given by the architecture itself, and based on that we have to see whether we really need this type of a structure. For example, in operating system, the user would be talking to computer, that means the user area, and the user area would be calling the APIs, system APIs, to get the functions from the kernel. So user would never talk or never use the kernel space. So there is no need for the user to interact with the kernel directly. So the layered architecture is applicable. If you see the network architecture, we have TCP/IP model, 5-layer model. The data link layer, which is L2, would be communicating to L3, network layer, and L3 would be communicating to transport layer. The L2, that means data link functionality, has nothing to do with the transport layer functionality. In such a case, L2 will never communicate with L4. So we can make the layered architecture of TCP/IP model. Although, if some coder or in some design diagram, you are planning to use the data link functionality in transport layer or vice versa, it is advisable to go through L3 so that the style you are using is a valid style even in diagram. Now come to patterns. We have discussed styles, which is a broad idea, a basic idea, what you are going to make. You are going to make buildings, and that buildings would be having apartments. Fine. What type of apartments? What would be the specification of those apartments? What features I have to add? Are there any constant? Those things would be defined by somebody else. And in software architecture, we call them patterns, which are standard and they have more restrictions, and in software design, we generally follow those restrictions. So what we have seen just now, like Blackboard, pipe and filter, layered architecture, those were styles, and those may be considered examples of patterns. For example, we need concurrency where different applications can make the task in a parallel manner. So let's say they can do multiple entries and multiple modification of the data. So which structure we have to use and which structure will fulfill the requirement from this. I hope you know I have to use data repository or Blackboard here, and Blackboard is a pattern. So I will use Blackboard. If you see distribution, the manner in which the components within the system, that means internal interface, communicate in a very different environment, I would go with pipe and filter structure, and that will behave as a very good pattern for this case. So in the architectural design, we have to see the context of the software in the design. We have to fix the external factors like other systems where our software has to communicate, different devices or the stakeholders. There would be different stakeholders. Designer is just one stakeholder. There would be users, there would be end users, and there would be resource managers. Something is called archetype, which is similar to a class or a component, and that represent just one element of the system behavior. So the designer checks the context, also modify the software components, and then choose a proper structure for the software development. So this is a diagram of our case study, safe house system, where there are some external modules, control panel, homeowner, which will use the system, sensors will use the system, and peers, different surveillance functions. And we have internet-based system and safe home product. So you have to check what are other devices, other factor which would be interacting and how they would be interacting, so that the functionality of the system with the integration with other components, other modules would be same as client has asked in the beginning.